Hello, welcome back. Okay, today we're going to do lesson 17. So as always, you can do your warm-up first and then come back to the video and I'll tell you how to do it. If you have forgotten, or at least you can see the answers. You can use the calculator, not so much for the first one, but for 2, and if you need to, for 3. All right, so go ahead and do the warm-up and, turn off the video, do the warm-up, and then come back to the video. We'll see you in a little while. All right, welcome back. All right, let's start. The first question, you know about it, but it says how much did they each bring along? So that's what they're asking for. So that's what our variable is equal to. In 7th grade math, it's really important that you define the variable. So I'm going to use X, and that's going to be the amount of money each brought. And then it's important that you can write the equation. So each person brought X amount of money, and there are 4 of them. So that's how much money they had. And then they start spending money, and because they're spending money, we're subtracting. And each person is spending $4.50 for their ticket, and they're each spending $1.50 for their drink, and there's 4 of them. And then it says together they have $12 left. So there's our equation. When we start, I'm going to go inside the parentheses and do that math first. So let's see, 4, 5, 6. And so we have 4x minus 24 is equal to 12. And we solve that equation. Not much room here. So we go like this, like this, like this. And we get our answer. And so then we put our answer over here that each brought $9. Hopefully that's what you found. This next one over here is a double discount or a double percent problem. First, this is on sale for 15% off, so that means that you're going to pay, 85%. So you're going to pay 85% of the $850. We're going to change that into math. We're going to use our calculator, and we're going to get our answer. And then we also have to pay sales tax, and they're asking how much does it cost altogether. So we have to pay 100% of that amount plus 6.5% of that $722.50. We change everything into math carefully. Put that into the calculator, and it comes out to be a number that's beyond our money system. I'll write it down, 4625. Our money system goes 2 places past the decimal point, so we have to decide, is that closer to the $769.46 or 47 cents? And the total cost, whoops, what am I writing here? Total cost is going to be $769.46. All right, and then down here we have a shelf that's 36 inches long, and we're putting 5/8 inch DVDs there, and they want to know how many we can put there. So this is a division problem because we're splitting something up. And of course we know we never really divide fractions. And again, you can do this in your head, or you can do this on paper, or you can use a calculator. And if you do that, this is the answer that you get. And then we have to answer the question. The question says how many DVDs, so we have to interpret that. And you can't have 57 3/5 DVDs, so we're going to say that there's going to be 57 DVDs that can fit. All right. That brings us to today's lesson. Today we're going to continue working with inequalities. So we're going to solve and graph inequalities. But today we're going to do just a little bit different here. We're going to do everything that we did yesterday, except for there's going to be a little bit of a twist, a little bit of a trick. Solve and graph inequalities with, very important, with negative coefficients. before we go on, I just want to remind you that if I go too fast, if the video is going too fast for you, definitely stop it, slow it down, stop it, rewind it. I guess you can slow it down to 85% too, but go ahead and do it at your pace. Don't let my pace determine what pace you need to learn this at. Okay, so what we're going to do is we're going to pick up where we left off yesterday. It says solve and graph, and there's our problem. So we're going to go ahead and solve just like you did yesterday. Something doesn't look right to me. Oh, I have to start over. Hopefully you didn't follow my lead because I did it wrong. To subtract 5 from both sides. There we go. Okay, now we'd go ahead and graph this. No equal sign, so we keep it as a hollow dot, and we want all the x's that are greater, so we're going this way. However, I'm going to write that. Doesn't work, and we'll show you why. Okay, according to what we have learned, the shaded area of the graph shows all possible solutions. So that means all of these points over here should work. So let's try x is equal to 0. Sure enough, that's a point that's on our line. So we're going to plug 0 into the inequality, and we want to know if that's a true statement. So you're going to write the inequality. It says -2 times x plus 5 is supposed to be greater than 9. So in for that x, we're going to put 0 because that's what they've told us to do. Then we're going to follow order of operations. Uh-oh. Uh-oh. Did it work? Nope. This is not true. So, what went wrong? I'm going to tell you what went wrong. Everybody's writing. What went wrong was that we divided by a negative. Up here, I'm going to highlight it. Up here, we divided by a negative number. When we divide by a negative, it's not going to be as straightforward as it was yesterday. So we have to be careful here. All right, so we're going to talk about the negative rule. This makes this just a little bit tricky, and you have to pay close attention to it. This is the rule. When we multiply or divide both sides of the inequality by a negative number, we must reverse the direction of the inequality symbol. Very, very important. I'm going to highlight that. This is the rule. Actually, I'm just going to circle it, highlighting. So let's go over that again. When we multiply or divide both sides of an inequality by a negative, we must reverse the direction of the inequality symbol. So this is a nice little hint down here. When you get to the very last step of solving your inequality, look at the number next to x. Is it negative? If so, you're going to have to flip your inequality symbol. So if it's less than, it's going to become greater than. If it's greater than, it's going to become less than. And of course, if it's greater than or equal to, it's going to become less than or equal to, and so forth. So let's try it. This is the same problem that you just did, only now we're going to do it the correct way. So we subtract 5 from both sides, doesn't change the inequality sign. Stays the same. Now what's happening next is that you're going to divide by a negative. As soon as you divide by a negative, it changes the direction of the inequality sign. Dividing by a negative changes the direction of the inequality sign. So you're going to write the x here. Yes, this is a -2, but because you divided by a negative sign, the inequality sign goes the opposite way. So let's graph that. We all go above the -2. There's still no equal sign, so we don't fill anything in. And then all the numbers that are less than that. So now we're going to check. And in order to check, what we're going to do is we're just going to choose one of the numbers that this line goes, that's included in this line. So like we could choose -3 because -3 is in our graph. So we're going to check where x is equal to -3. We're going to go to our equation. We're going to write our equation. And in for the x, we're going to put -3. And we're going to see if our inequality is correct. Just to make sure that you know what we did, we just put that -3 in place of the x. We do our math. And voila, it worked. 11 is the bigger number between 11 and 9. So when we multiply or divide by that negative number, the inequality sign changes. It flips to the opposite side. That's the lesson for today. Let's practice. Solve and graph, and then check that your answer is correct. So the first thing we do is we solve. Adding and subtracting, nothing changes ever. Inequality sign gets brought down exactly the same. If we multiply or divide by a negative, then the inequality sign changes directions. And there it is. We divided by a negative, so when we get our answer, the inequality sign is going to switch directions. It used to be a greater than, and it becomes a less than. And then we need to graph. Don't have much room here. Remember the 0, the -4, a number bigger, a number smaller. Decide if that's going to stay hollow or you're going to fill it in. No equal sign, so it's going to be filled in. And then we want all the numbers that are smaller than that. Then we're going to go ahead and do our check. And all we do is choose any number that we'd like to that's on our graph. So I'm just going to use this one right here. I'm going to use where x is equal to -5 because that's definitely on our graph. So I'm going to take the inequality, and wherever there's an x, I'm going to put the -5. So here I go. It says -3 times x, which is -5, minus 4 is greater than 8. And then I'm going to do my work. And sure enough, 11 is bigger, so I know I've done it correctly. So once again, when we're multiplying or dividing by a negative, the inequality sign switches direction. Let's try again. Remember, if I go too fast, and a lot of this probably is too fast, then stop it, slow it down, repeat it. Everybody solves the inequality. Adding and subtracting, no sign change ever. All right, now we decide what we have to multiply both sides of the equation. We'd like to divide by -1/4, but we can't, so we multiply by -4/1. And we look, what did we do? Well, we multiplied by a negative number. If you multiply by a negative number, then the inequality switches order. It changes to the other direction. Then we graph. No equal sign, and less than. All right, we're going to check. I always like to check 0 if it is part of our graph, because mathematically 0 is very, very easy to manipulate, especially since we have to take -1/4 and multiply it by that number. I don't have to worry about it because obviously that's going to be a 0. And so 0 minus 2, -2 is greater than -3. We can think about that. Here's 0, here's -1, here's -2, here's -3, and sure enough, -2 is higher than -3, and so we're good to go. All right, I'll do a couple more with you. Everybody does, oh, we didn't do them in order. That's all right, everybody does number 2. Adding and subtracting, nothing. The sign does not change. Ooh, this time we divided by a positive. No change. No change. Dividing by a positive, there is no change. So you only change if you multiply or divide by a negative number. All right, above the -1, oop, there's that. We have to fill it in. And less than. We still check, even if we're not changing the direction. We still check. I'm going to use 0 again because 0 is easy mathematically. 2 times 0 minus 5 is supposed to be less than or equal to -3. And again, you can think about this on a number line. You've got -5 and -3, and it says that -5 is further down. Yep, sure looks that way. All right. Keep working. Adding, nothing changes. Divide by a positive number, nothing changes. Okay, decide what you're going to do with that open dot. All the numbers that are less than 3, and then we check. They've been nice to us because a lot of times 0 is part of our answer, so when I check, I'm going to check x is equal to 0. This one's pretty easy because any negative number is always going to be smaller than the positive number. So yep, that's good to go. All right. Finish number 5. Hold on. Got it on the wrong thing. Ignore all that. All right. Everybody's doing number 5. Uh-oh. Don't get complacent. We divided by a negative. If you divide by a negative, that inequality sign has to change. The inequality sign goes from a greater than to a less than. Greater than to a less than. Everybody changes the inequality sign. Let me point that out to you. Greater than or equal to, less than or equal to, because we divided by a negative sign. Everybody graphs it. Look at it, decide what you're going to do with the dot. And then lastly, we need to check. I can't use 0 because 0 is not part of our graph, so I don't get to use 0. So I'm going to use, whoops, darn it. Let's see, maybe I can undo. Oh, look at that. Okay, so let's use maybe -5. All right, the equation, -3 times -5 minus 3 is supposed to be greater than or equal to 9. Let me just show you one more time what we did over here. We just took this x, and this x became our -5. We do our work. And sure enough, 12 is bigger than 9. So, good job. All right, let's go on to page 59. It says we flip the inequality sign when we divide by a negative. But if we are dividing into a negative number, for that example, what happens? So what they want you to do is they want you to solve this equation and then check and see Do you change the inequality sign? Does the less one become greater than? Well, tomorrow on your key, you'll be able to figure it out. Everybody tries it for tonight or today. Everybody does the rest of the page. Make sure you work carefully, and then I'll have the answers for you tomorrow.